So here we are back at it with Godot docs, getting started our first 3D game, designing the mob scene. Let's throw this over into whatever you call this. I don't know what to call this, but honestly, this is actually making it to where I think Windows 11 might actually be a lot better than Windows 10. This right here, actually, I don't know what to call that though. I'm sure it has a name. That being said, here we are. So we're going to be designing the mob scene. In this part, we're going to code the monsters, which they're going to call the mobs, and we'll call them that too. Why not? In the next lesson, we're going to spawn them randomly around the playable area. Okay, cool. We're going to design the monsters themselves in a new scene. Okay, the node structure is going to be similar to the player.textScene scene. And we're going to create a scene with, once again, a character body. Hold on a second. We're going to create another scene with a character body 3D node as its root. Let's do that to start with. Let's come over here with the new scene right here. And what was it? Character body 3D? So let's push Control A. We already have that right here. So here's character body 3D. Create it. And then we're going to name it mob. So mob like this. Boom. We'll add a child node 3D. All right. So let's do that. What is it? Control A. Node 3D. Right there. Create it. All right. And name it pivot. All right, pivot. There we go. Now we're going to drag and drop the file mob.glb. Who cares? From the file system doc onto the pivot to add a monsters 3. I was thinking about glib, glab, glob, glub, and gleb. What we can call it. Let's call it a glub. No, I don't like that one. Glib. Like a glib tongue. Anyway. Mob.glab from glab. Mob.glab from the file system doc into the pivot to add the monster 3D model to the scene. Anyway. Let's do that. Monster mob.glib. You just say all kinds of the gloob. Anyway, whatever. Let's go. So there's that. We can rename the newly created mob node into character. Sure. Let's do that. Huh? Why not? What? Whatever. I mean, I guess it's an NPC, right? But it's a mob though. Whatever. All right. So it doesn't matter. We'll name it what we want when we start doing our own business. I guess it needs to be character because we got mob here. Whatever. Makes sense, I guess. So we're going to do another one. We're going to put a collision shape in the mob node. So let's go over here and Control S, Control A, I say. Collision shape 3D right here. Create it. All right. We did that. In the inspector, assign a box shape 3D to the shape property. We can do that right here. Box shape 3D. Cool. Pardon me. We should change its size to fit the 3D model better, and we can do so interactively by clicking and dragging on the orange dots. Is this more? This is more dots than we had on player. What was player? We had a sphere, and this one's got a box. Okay. The box should touch the floor and be a little thinner than the model. I mean, it doesn't matter, but... Whew. I guess it's just showing us... what we need to do in box situations. So let's come over here to perspective view. Collision shape 3D. I guess. Whatever. Anyway, zoom in. Alright, so... we should change this by dragging the orange dots. Alright, so here's an orange dot right here. Ah, yes. So, according to this picture here, we want it to look like this. We want it to be on the darkest part. We want to use the darkest part as our guide. So, there's one. Let's turn this thing around. Let's move this one. We're going to have to do all 6 axes, I think. Let's keep moving it. That looks good. Alright, let's do this one over here. How do we pan? No, not like that. No. Okay, look. If you hold down shift and do middle mouse button. So middle mouse button, we can rotate it like that. And if you hold down shift and do middle mouse, we can pan left and right. Cool. All right. Let's bring this out a little more. I mean, it doesn't need to be perfect, obviously, but let's just try for it just because, you know, why not? Why not try to at least get it like real nice and what's the word? Something. Nice and crisp. Nice and professional. You know, because we're trying to make money here, you know what I'm saying? Come on out. A little bit more. There we go. And then we got the bottom 2. Let's bring this up. Touching it. A little more down. Is that good? I guess so. All right. So let's zoom out with a little control minus. I don't know if the mouse wheel works because my mouse wheel doesn't work. So if it does, use that. All right. So we did that. Okay. The box should touch the floor and be a little thinner than the model. A little thinner? Well, then let's just bring it in a little bit. I'm holding down control when I did that. That's why it was going like that. Anyway, so it needs to be a little thinner, so says the thing right here. So let's just bring it in just inside these lines. But remember, we're going to need to actually test it all out for ourselves at some point to see if we actually, because look, if we like the feeling, if we as the developers like the feeling, we can guarantee that at least a solid percentage of the people feel the same way. You know, there's always going to be somebody complaining, right? But if we like it, you know, what else do you want to do? You know what I'm saying? All right, so there we go. So now it's thinner. If the box is a little too big compared to the 3D model, we may die at a distance from the monster. True. And the game will feel unfair to players. Yeah. Here's the box. All right, anyway. Actually, there we go. All right. Notice that the author's box is taller than the monster. It is okay in this game because we're looking at the scene from above and using a fixed position. I guess so, but we already made it a little bit thinner here too. All right, cool. Collision shapes don't have to match the model exactly. True. It's the way the game feels when we test it that should dictate their form and size. True. Also, like I just said, I think. but this is a little more concise. Removing monsters off screen. True. So we're going to spawn monsters at regular time intervals in the game level. If we're not careful, their count could increase to infinity, and we don't want that. That's a memory leak right there. Okay. We're gonna, when you go into like Reddit, and if you go on to like articles and stuff like that have a lot of C++, when they talk about memory leak, they mean this stuff. Like if we keep spawning monsters and they keep going off the screen and just go forever, that's memory leak. Okay. And so to get rid of, so we have to get rid of them once they get off the screen, or they actually won't be gone. You know, I mean, they'll be gone, but they'll still be, you know, quote unquote processed, even though they're not there. Anyway, let's go. Each mob instance has both a memory and processing cost, and we don't want to pay for it when the mob is outside the screen. True. 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 It really makes me think. Ugh. It makes me think, how are we going to do this stuff? But we'll get to it, because like even now this stuff, like when we do this, it has to delete the rendering that looked like this. This rendering needs to be deleted every time, and this rendering needs to stay on the screen, and those ones need to be deleted. I guess that's how that works. I don't know, honestly. I don't know. We didn't get that deep into C++, but there's something going on there. We'll get to that later. Once a monster leaves the screen, we don't need it anymore, and we should delete it. True. Godot has a node that detects when objects leave the screen, visible on-screen notifier 3D. Okay. And we're going to use it to destroy our mobs. Cool. So here's a note. When we keep instancing an object, there's a technique we can use to avoid the cost of creating and destroying instances all the time, called pooling. It consists of pre-creating an array of objects and reusing them over and over. Okay. When working with GDScript, we don't need to worry about this. The main reason to use pools is to avoid freezes with garbage collected languages like C# or Lua. Okay. We'll figure all that stuff out later. GDScript uses a different technique to manage memory. Okay. Reference counting. All right. Which doesn't have that caveat. Okay. We can learn more about that here in the memory management section of the manual. Yes. All right. So let's get back to it. We're going to have to learn all that stuff at some point. I mean, or not. I don't know, honestly, or not. I don't know. Like, I don't need to know how to make I don't need to know how to make steel to use a fork, you know what I'm saying? Anyway, I don't know. Maybe we don't need to know like the deep stuff about computers these days. Maybe it's just, you know, whatever. Because like, I don't know. Let's go. Select the mob node and add a child node visible on screen notifier. Okay. Mob, Control A, visible on screen. Visible, that's not how you spell anything. Visible on screen enabler notifier. Boom. Oh, there it is. Another box, pink this time, appears. True. When this box completely leaves the screen, the node will emit a signal. Okay. Resize it using the orange dots until it covers the entire 3D model. Yes, that makes sense. Oh. Oh, what? I guess it doesn't matter on the Z. Which one's Z? Blue is Z. Oh, yesterday in the thing when I was talking about, okay. Z is the direction. And right now, we haven't set up the direction in the code. So now the direction's pointing down when we need the direction. No, it is. This direction, we need to flip it to where the direction points this way, right? Anyway, whatever. Or not. I don't know. Is this the positive? Positive is down. Positive is down, right? And then this is right. But I thought, no, this is Y though. So this is up is gonna be positive. I don't know. Let's go. Let's keep going. So we got that. Resize it. We did that. Coding the mob's movement. Okay. So let's implement the monster's motion. We're going to do this in 2 steps. Let's actually push save over here. Control S. Let's do that later. Let's implement the monster's motion. We're going to do this in 2 steps. So first we'll write a script on the mob that defines a function to initialize the monster. First we'll write a script on the mob that defines a function so we're going to initialize the mob first, okay? Then we'll code the randomized spawn mechanism in the main.text scene and call the function from there. Okay, so we're going to make the randomizer in the main.text scene. Okay, so we're going to initialize it here, and then we're going to make the randomizer. Okay, in main. Okay. So now we're going to attach a script to mob. So let's click mob, attach a script. I wonder if they want it empty. I guess it doesn't matter. Create it. All right. So we got that. And so here's the movement code to start with. We're going to define 2 properties, min speed and max speed, to define a random speed range, which we will later use to define character body 3D.velocity. Okay, so it's just like the other one where the mobs had random speed. So let's Control A, Control V. All right. So we've got the min speed and the max speed, and we're going to do a random between there. Then we're also going to do the move and slide here, like we did with the player. Oh, player. Like we did with the player down here. Okay. Yes. I said a lot of stuff about this. Like this is okay. Hopefully you understood something about this stuff. We'll get to it later. Anyway, there we go. So we got the move and slide right here when we do the physics process. All right. So let's go down here and read this. Similarly to the player, we move the mob every frame by calling the function move and slide. This time we don't update the velocity of every frame. True? We want the monster to move at a constant speed, and leave the screen, even if it were to hit an obstacle. Okay. Is that what we're doing? I guess that's what we're doing. They're just going to goes through each other and then do a game over when it hits the player. I guess that's what's happening. Anyway, so let's keep going. So we need to define another function to calculate the velocity. All right. This function will turn the monster toward the player and randomize both its angle of motion and its velocity. What? This function will turn the monster toward the player and randomize both its angle of motion and its velocity. Why is it going to turn the monster towards the player? Whatever, we'll figure it out. The function will take a start position, the mob's spawn position, and the player position as its arguments, okay? And we're going to position the mob at start position and turn it toward the player using the look at from position method, okay? And then we're going to randomize the angle by rotating a random amount around the y-axis. And then below rand f range outputs a random value between pi, negative pi over 4 radians and pi over 4 radians. So that's, isn't like half, pi over a half is like, pi over 2 is half of a circle, right? Like pi is a quarter of a circle in radians, right? Or not. I don't remember. We'd have to go over that again. Anyway, so let's get this and add it to the code. So let's grab this and put this after the physics process. Make sure to bring it back because this function called from the main. Come on now. All right, let's go over to main. Main? Whoa, 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 whoa. From the main scene. Okay, so, okay. We didn't, it's not the main script. I get it now. Okay, so let's drop this down. There it is. So this function will be called from the main scene. All right, from here. In C. In C. In C. In C. What the what is that? Have you ever seen that before? In C. Oh, funk. Why didn't it get... Oh. Funk. My bad. Let's go. All right, so we got funk initialize, start position, player position. There we go. We position the mob by placing it at the start position and rotate it toward the player position so it looks at the player, okay? Look at from position, start position, player position, vector 3 up. Whatever up is, like, I don't know if it's like, you know, whatever. We'll go through that later. We're going to rotate this mob randomly within a range of 45 and of negative 45 and 45 degrees so that it doesn't move directly towards the player. Okay, yeah, makes sense. Rotate Y, rand, F range. 45 degrees. Half of, okay, so, okay. Pi is 180 degrees. That's what's going on. Pi is 180 degrees. 180 divided by 4, 45, right? Exactly. It's 45 times 2, 90. 90 times 2, 180, right? Of course. So that's what's going on here. Okay, great. Now I see what's going on. So it's going to look at from position. So this is a built-in thing, like move and slide and rotate. Okay. All right, let's go. So we got a random position. Now we need a random speed dot randy range, and this will be useful as it gives random and a random int value. What? Hold on. We got a random position, and now we need a random speed. Okay. Randy range will be useful as it gives random int values. What? Randy range will be useful as it gives random int values, and we will use min speed and max speed. Jeez Louise. Hold on a second. This is sorry for the bad. Does this look like a normal paragraph to you though? That's not like these usually words sentences start with capital letters. Anyway, let's try again one more time. So we got a random position, and now we need a random speed. Randy range will be useful as it gives random int values, and we will use min speed and max speed. Random speed is just an integer, and we just use it to multiply our character body .3D velocity. Man, I hate it when they do this. These aren't words, man. Don't use these as replacements for words. Just use the words, bro. After random speed is applied, we rotate character body 3D velocity vector 3 towards the player. Anyway, let's just get this and let's put it in here and then let's look at it. Randy range. Come on, bro. All right. No, what? Well, come on. All right, we got to take all this right here. I guess from the V to right here. Let's copy that. Let's toss it in right here. What the? What is going on? Or what's going on? Oh. Okay. All right, let's do this. There we go. Copy it. Paste it. All right. All right, so after we rotate it randomly, all right, we're going to say var random speed equals Randy range min speed max speed. So this is just going to give choose whatever random speed based on these. All right. And then we got velocity equals vector 3 forward dot random speed. So this is probably going to say forward. What does that mean? Let's do a print statement real quick. Print vector 3 up dot up. Is that not good? Do we gotta do this inside the physics body? Are we? All right, let's grab this and let's do this here. Let's get this and get this out of here. Let's run it. Yeah, save it. Okay, so this is what the forward, this is what up looks like. Now let's see what forward looks like. Copy this, slap it in here, run it. All right, so forward is gonna hold on, let's come over here. Let's say what's the random speed? Okay, so it's gonna be a random speed. So let's say forward times whoa. Times 50. Let's see what that does. Okay, so that's what's going on there. All right, cool. All right, so now we know what these are doing. Forward is affecting the third argument in the vector 3 or whatever it is. And then up is the second one, is the Y. So the Z, which forward is -1 times 50. Okay, and that makes sense because now we know this would be +1, right? So it needs to go forward using the -1. Boom. All right, makes sense. Let's get back to the script. So there's that. Whoa. There's that. Let's go to the next part. So leaving the screen. We still have to destroy the mobs when they leave the screen. To do so, we're going to connect our visible on-screen notifier 3D nodes, screen exited signal to the mob. Oh, yeah. We haven't done signals in a while, have we? We have not. All right. So head back to the 3D viewport by clicking on the 3D label. We can also press Control F2. Maybe next time. I forgot about that already. Select the visible on-screen notifier 3D node and on the right side of the interface. What did you say? Visible on-screen. Boom. This one here. We're going to navigate to the node dock, right? Double click the screen exited signal. Okay. And so we got that right there. We're going to connect the signal to the mob. Okay. Yes. Connect it. This will add a new function for us in our mob script. It did. Okay. Oh, man. Oh. Okay. So on visible on-screen notifier 3D screen exited. Oh, what? Hold on. So this will add a new function for us in our mob script. On visible on-screen notifier 3D screen exited. This one. Dang. It's a big one. All right. Anyway, from it, we're going to call the queue-free method. This function destroys the instance it's called on. So yeah, we're going to do queue-free right here. QU, listen, QU, EUE, underscore free. Boom. Great. Okay, great. So our monster is ready to enter the game. In the next part, we're going to spawn the monster in the game level. So here's the complete mod.GDScript for reference. Let's check it. All right, we got that, we got that, we got that. We don't need this print statement. Func initialize, yeah. Look at from position, we got that. Rotate Y, we got that. Random speed, we got that. Velocity equals vector 3, we got that. Velocity equals velocity rotated, sure. And then we got this one right here with the queue free. Great. The signals. We gotta, I'm sure that these are very useful, but I'm still not too sure what's going on with them and when and where and why, you know, but whatever. So there's that. And now we can go on to our user contributed notes. It would be nice if we explained what the local transformation means. I don't know what that means. Yeah. I don't know what that means. All right, so let's go down here. Next. There we go. All right, so now we're on to spawning monsters, and we'll see you next time.